Hello, my name is Mike Bingle Davis, and I currently work for Kirkwood Oil and Gas in Casper, Wyoming. For the context of this particular presentation, I'm speaking on behalf of the NAMCO, which is the North American Mining and Minerals Company. And what I'll be talking about is a locality known as Lone Mountain. It's a tertiary quartz monzonite intrusive forming a half window on a broad west plunging aniform located in Elko County, Nevada. And NAMCO acquired this property in the early 1960s. This slide illustrates where Elko County is relative to the other counties located in Nevada, and that's in the northeastern. It's highlighted red. Close up in the middle, or the center, actually shows you a close-up of Elko County. Where Lone Mountain is, it's on the southern end of the Independence Mountains. The Lone Mountain area is also known as the Merrimack District in Elko County and is approximately 25 miles in a direct line northwest of Elko, Nevada. This slide is a close-up of Lone Mountain itself, and it is referred to as Nanny's Peak, and that is because of the amount or number of locations in Nevada that are referred to as Lone Mountain. This is actually Nanny's Peak and the Nanny's Peak intrusion. We also have two topographic cross sections, one going north to south, and that illustrates approximately 30 degrees slope on both sides, and an additional cross section from west to east, which illustrates the eastern gentle sloping of around 5 to 24% towards the peak, and a sharp contrast on the western side with 60% slopes flattening and then a 35% slope to base. The maximum elevation of the peak is 8,780, and that's an elevation difference of the base to top of approximately 2,800 feet. This slide again shows the location of the Lone Mountain property or the Merrimack District in relation to the Independence Canyon, Jarrett Canyon trend on the north going north-south, and the Carlin trend, which is basically northwest to southeast. The map on the far right represents approximately 17 locations that the Nevada Bureau of Mines recorded in 1991, which illustrate various forms of mining and exploration, most of which are surficial. There are 3 formally designated mines located on the property, but only one that was really worked. The different colors are representative of blue being barite or barite deposits, and the red are different types of deposits, including lead, silver, gold. So far to date, the Carlin trend is responsible for the production of 84 million ounces of gold total, and along the Independence Jarrett Canyon trend, there's an approximate 8 million ounces of gold that's produced. To start off the geologic setting, I'll use this Blakey map illustrating the position of the states and what type of geological features you're going to see occurring in the late Devonian. And in this area, early and middle Paleozoic rocks were deposited in the north trending Cordilleran geosyncline, and the deposition is postulated to have occurred in a marginal basin that's bounded on the west by an island arc system. And Lone Mountain itself is located in a gradational facies boundary between eastern deeper water dolomites and a transitional suite to the west of a limestone clastics of early to late Devonian. The following 2 slides were constructed by the Nevada Bureau of Mines to illustrate the differences and the changes that occurred on the eastern versus western Nevada. So to the left you have, of course, western Nevada, and to the east or to the right you have eastern Nevada. Diagram 1 essentially is the end Devonian Cordillera geosyncline, and that covered all of Nevada. And the volcanics are located in the west, and clastics, and carbonates in the east, and a transition between the two in the middle. In the cartoon labeled 2, you have an early to late Devonian orogenic event, which I indicated by the arrow pointing up, which caused uplift, folding, and erosion in western Nevada, and an increased deposition of orogenic clastics in central Nevada, and some folding occurring. Lone Mountain itself is located in the gradational facies on the boundary between the eastern Dolomites, or the deeper waters, and the transitional suite of limestone and clastics of early to late Devonian. Continuing on with the final two diagrams illustrating the sequence of events in Nevada. You have the late Devonian, early Mississippian continuation of folding and uplift. Illustrated in diagram 3, you have the antler orogeny of the late Devonian, which essentially closed the basin and displaced a lot of the deep water Dolomites eastward onto the shallow water transition limestone clastics eastward into the basin. And early to late Devonian orogenic events caused uplift, folding, and erosion in western Nevada, with increased clastic deposition occurring in central Nevada. All of this was occurring during and after the emplacement of the Robert Mountains Olocothan during the Mississippian period. And you can see that in diagram 4 as the Robert Mountains thrust fault pushes itself on top of those earlier orogenic clastics. This slide shows the general geology as depicted in Google Earth for the Nanny's Peak and Nanny's Peak intrusion, or Lone Mountain. You still have your mining and claim locations there depicted on the map, as well as that intrusive core, and it being surrounded by your dolomites, cherts, limestones, calcareous shales, cherts, quartzites, and greenstones. And the red material that's overlying the majority of the subsurface to the west is the older silicic ash flow tuffs. So looking at that Crawford diagram at the bottom, it basically shows you that what happened was the intrusion of the Nanny's Peak cut through those folded early orogenic clastics and transitional materials and pushed upward and created alluvial type fans to the east and more of a volcanic / altered dolomites and limestones. This is a geologic map it's probably the most comprehensive, and it was produced by Lovejoy in 1969, and essentially illustrates the end result of the thrust and uplift event that produced the Lone Mountain, or Nanny's Peak. And the majority of the materials on the eastern side are Cenozoic welded and silicified tuffs, and that's being a volcanic ash that's consolidated into a solid rock. The core there depicted in the orange is a quartz monzonite porphyry and altered diorite, biotite, quartz latite. That's the fine grain equivalent to the quartz monzonite, and those two are differentiated based on their different cooling types. And you can also see the eastern and western facies, cherts and shales and limestones and shales, and you can also see the two faults located on the northern edge and the southern edge of the core. And 3 cross sections were drawn across this complex in this particular map set, and I'll go through each one of those. The first northernmost cross-section is A to A prime, and it's basically through the core of the quartz monzonite porphyry intrusion of the Cenozoic. And the biotite quartz latite is in olive, and the quartz monzonite dike is in kind of an orangish color. And the difference is that the monzonite cooled more slowly. That resulted in larger phenocrysts, and the latite cooled more quickly, so it's more fine-grained. And the thrust faulting seen between the western chert and shales in pink are Ordovician and Silurian in age. You can see that in the cross-section down there. There's extensions of the faults out of the section so that they're more pronounced, and I also outlined them. And the thrust faulting seen between like I was saying, the shales and cherts in pink are onlapping onto the limestones in blue, which are Devonian in age. And so the younger age limestones in the center and the older cherts that are bounding on top are essentially what produces that fenster or window. Continuing on with the Lovejoy cross-section set, we go to the B to B prime. And again, you can see that the majority of the materials on the eastern side of Lone Mountain are Cenozoic welded and silicified tuffs. And the core, again, is a quartz monzonite porphyry and altered diorite / biotite quartz latite. The primary thrust can be seen in the west. Again, you can see that fenster or window being created, as well as an additional 2 dikes that are produced that are going through the limestone that you see in the cross section. And the fault on the east is sub-Cenozoic, but the fault's been extended to illustrate its presence. It's been covered up, so it's underneath the surface material. This is the third and final cross section that was produced by Lovejoy, and it's further to the south, so it's away from that central quartz monzonite stock that we've been looking at in the first 2 cross sections. And it primarily focuses on the anticlinal structure and the separation of the lower and upper plates of limestone and cherts and the shales of the Ordovician Silurian. The boundaries between the plates are seen in the fractured nature of the limestone that you can see in the cross section in the light blue. As you transfer, you go from pink, from left to right, or from C to C prime. You go from the pink materials, the Ordovician materials, into Devonian fractured and then Devonian limestones. And as you move further east, you've got just that infill, alluvium. And you also see the anticlinal nature of the structure when it's definitely more evident when it's not as affected by the intrusion. The intrusion, of course, is what produced it, but you don't actually get to see the intrusion. It's not expressed in this cross section. And if you have any questions at this point, I am available to answer them. Thank you for attending, and I hope you enjoyed my talk. Thank you so much.